Hello everyone and thank you very much for watching. This is me, Mr. P, and welcome back to another episode of the Proxmox Home Server series. I had the idea to set up the PXE-Boot-Server inside my Proxmox environment and use that to boot the Raspberry Pis inside my home network. And I spent quite a few days trying to figure out how to make this work, and just I know I'm doing something wrong because it just doesn't work as it should. But with IT and probably everything in life, when you're trying to fix the problem, there is a big chance somebody already did that for you and even created the tools to make the setup process much easier. So I found the GitHub repository by the name of Byte Tips, and he's created the RPi-PXE setup script, which will basically set up all this just with a couple of, well, not a couple of clicks, but much easier than I was going through a command line and setting up everything from scratch. I know roughly how everything works, but it's just like I said, I just can't get that to fully function. So in this video, I will demonstrate to you how this script runs, what you need to do to make this function, because the script is more designed to run on the Raspberry Pi and use one Raspberry Pi as a server, where another Raspberry Pi will be used as a node. So there's a couple of things you need to install extra before running the script on your LXC container or virtual machine, before basically getting everything set up, all this setup done. So let's start by going inside the Proxmox and setting up ourselves the LXC container. I will use Ubuntu LXC container, but you pretty much can use even, let's say, Ubuntu VM to get this working. I'm going to use LXC container for this video. So first thing, inside my Proxmox YT under CT templates, I already have a template downloaded. If you don't have Ubuntu template, you need to go to the storage unit where you keep your CT templates, click on a template, and then search for Ubuntu, and then load the 2204. 2304 doesn't work for some reason on my system. 20-04 is a bit too old. I'm just going to use the middle, which is 2204 for this video. So this is my template that I'm going to use. I'm going to click Create CT. ID number automatically picked up by 100. If 100 is being used, just pick any ID number that is free. So I'm just going to use, let's say it's a lucky number, 777. The host name and the name of the container will be PXE server-YT. This container needs to be privileged. With VMs, it's pretty much, you don't need to do this, but for the containers, you need to select is it privileged or not. I need to make sure that container is privileged. That's why I will untick that. Give it a password for the root SSH access. Under templates, I will select my Ubuntu 2204. Under disks, 8 GB is plenty to boot up to, I would say, 2 free Raspberry Pis. So I will leave 8 GB just to boot one Raspberry Pi will be plenty. Under CPUs, 1 core is fine. Under memories, I will increase that to 1 gig just to speed up the installation. But actually, let's make 2 gigs just to speed up everything. You know what? I'm just going to do 2 cores and 2 GB of RAM just to make the installation process much faster. Under networks, I'm just going to choose DHCP to obtain IP address for this container automatically, and the DNS everything by default. And the confirm, I will not select start after created because I need to do a couple of more things to this LXC container. I will click finish, and Proxmox will create this container in no time. So task OK, container is created. Close that. I will select the container and I will not start, but I'll click options, features, and click edit. I will enable nesting, NFS, and SMB. NFS and SMB ticks allows this container to host NFS and these Samba servers, and nesting is allows to run all the background processes without interference. So there's 3 ticks, or well, the most first one is not allowed because it's unprivileged only. So second, third, and fourth needs to be ticked. Click OK. So as you can see here right now, it's changed to mount equals NFS, CIFS, and nesting. And I'm just gonna go back to console and press start. So the container starting for the very first time. Wait for the container to start. Come on, where are you? Here we go. So username is root. The password is the one I created during setup process. And a couple of things we need to install to get everything working. First, I'm gonna go and update the packages. Then I'm gonna go and upgrade the packages. Give auto yes to the request. I'm daisy chaining the command. So that means that once this is successfully finished, run that. And when this is successfully finished, run that, which we're going to install 2 things. We need to install Git to Git clone the repository, and we need to install NetTools. NetTools will allow this container to scan our network to detect the Raspberry Pis. once you're running on, let's say, VM, that this package probably not required. It's already installed, but still I'm suggesting to run this just to make sure it's definitely installed. I'm going to say -y at the end. So this command will run. Once this is successfully finished, this command will run, and when this command is successfully finished, it's going to run that. And press enter. So while this is happening, we need to get ourselves the Raspberry Pi OS image. I'm going to use the Raspberry Pi imager for that. So we're going to run imager. I'm going to choose OS. I will select the Pi OS, but before that, some of the Raspberry Pi 4s that you, for example, let's say bought in the past month, maybe 6 months, they already have NetBoot Automatic enabled. If you're not sure if it's enabled or not, it's not a harm to run the Raspberry Pi imager, select MISC, Utilities Images, select bootloader, Network Boot, and then choose microSD card. Write that into microSD card. Put microSD card into Raspberry Pi. You don't need to plug in the network for this. You just power it on and wait for about 30 seconds, and that will flash the configuration to Raspberry Pi onboard memory to tell the Raspberry Pi that if microSD card fails, boot from the network. In our case, microSD card will not fail because there will be no microSD card at all, so it automatically will jump to network boot. My Raspberry Pi already has that setup done, so I'm just going to go back, select Raspberry Pi OS, 64-bit Pi OS Lite. I just need CLI, I don't need the desktop environment. Select the microSD card, and I'll click on the gear icon because I want to give the host name something different. So I'm going to say RPi-PXE node-YT, enable SSH, and I'll give the password, something easy to connect. Press save, write, and go for it. Pop OS asking for authorize that, that's fine. So right now Raspberry Pi imager flashing Raspbian OS to my microSD card with all the pre-configurations I selected. Let's go back here, and this is all set up done, which is great. So right now we have the updated and upgraded the LXC container with NetTools installed and GitHub installed as well. Let's go to the GitHub repository and select all that. Let's select all that. Come on, here we go. So step 1, clone this. So I'm going to say clone all this. I will clone that into my root folder, which is fine. It's not a big deal I can even create a folder within the folder, but root folder is going to be fine for me. I'm just going to right click, choose paste, and press run. And right now repository is cloned and it's created a folder for me, RPi-PXE. I will navigate into this folder, and I have 2 files, readme.md and RPi-PXE sh. We need to make a sh file executable. To do that, we need to write chmod space plus lowercase x, which this command of this flag passes the information that the next file needs to be converted into executable file. Enter that. So now this file turns green. In my case, it turns green. In your case, it might be different depending how you are accessing this container. As you can see right now, it says, okay, this is made executable. We are happy to run. So this is fine. Let's check how our image is doing. So it's almost done with that. So let's wait for a couple of seconds for this to finish. Click OK, continue, and close that. So now I'm just going to take microSD card from the reader, which is stuck. So microSD card here, I will connect or insert the microSD into Raspberry Pi, and I will connect that into my server rack and plug in the power by using a power PoE. So Raspberry Pi inserted and it's all ticking nicely. So while the Raspberry Pi is booting up for the very first time, we can run this script. To run the script, you need to navigate into a folder where the script is located and type /RPi and then a full text, full name of the file ending with the extension sh. Press enter. This layout is a bit wonky. Here we go, actually a bit more. Here we go. RPi-PXE imager brought to you by George Paybon. I hope I'm pronouncing your name correctly. And this is the steps we need to follow to get everything working. Not all of them we're going to use, but majority of them will be used in this video. So step 1, install RPi-PXE server. Press 1. Would you like to do? I am picking option 1 and press enter. And right now we'll go and update and upgrade packages, which is not necessary. We already did that, but that's fine. And right now it's installing NFS kernel server and Samba. These are 2 to run NFS server and a Samba server, and it should install DSM DNS mask, here we go, to allow Raspberry Pi to detect that there is the PXE server running inside our network. So it says press enter to continue. I'm going to say yes. And right now it tells you, please read this carefully. And this is more tailored to Raspberry Pi users when they're using Raspberry Pi as the server, because it tells you that you should not attempt to run this from SD card, because SD card longevity will be shortened, because a lot of things will happen on SD card. So it's recommending to use NAS. But my LXC container runs inside the Proxmox, which is hosted inside SSD and M.2 NVMe. So it's much longer longevity than my micro SD card. So I'm happy to pick option 3, which is use a boot device instead. I'm going to say option 3, press enter. And it tells you we will create this folder. So inside root, they're going to create a PXE folder with 3 subfolders: boot, file system, and images. And images will have another 2 subfolders, which is going to be boot and file systems. And this explains to you what each of them will contain. So I'm going to say enter and enter that. And it's doing the rest of the things. It says, we want to restart this just to make sure everything is fine. I'm going to say fine by me. And right now the LXC container will automatically restart. LXC container is back up and running. So we're just going to say login back in. I'm logged in straight away into root folder. This is the folder where the script lives. And run the script again. So we done step 1, install RPi-PXE. Uninstall, we don't really want to do that. See information about this Raspberry Pi. So if I choose free and press enter, it gives information about this Raspberry Pi, which technically is my LXC container, which runs on Intel NUC 12 Gen with 16 cores, i7-1260p, and serial number and IP address and etc. sits here. So I see OS version Ubuntu 22.04.2 LTS. That's fine. I'm going to click this. And now we're going to go, and I don't want to change my host name. Identify Raspberry Pis on the network. I'm going to press 5 and press enter. And what's happened right now is went and checked my network and detected all the Raspberry Pis. That's why we had to install net tools. On Raspberry Pi OS, when you're running this on the Raspberry Pi and you're creating Raspberry Pi as a PXE server, this is already pre-installed. It's probably going to be pre-installed on your VMs already, but in my case, I had to install it manually. And it's detected 2 Raspberry Pis currently active in my network. scar.fritz.box, this is my octoprint, and RPi, this is the one we're going to use. So I know my IP address for Raspberry Pi is 32. I'm going to click enter on that. So it says, okay, we're done step 5, get information about the Raspberry Pi. I'm going to press 6, press enter, and we're going to enter the IP address of the Raspberry Pi, which we're going to use for PXE-Boot. Press enter. Which username you want to use? I'm going to choose Mr. P. This is the one I chose when I was doing Raspberry Pi Imager. Press enter. I'm happy with that, and get that one going. So that's it. So it gives me information about this Raspberry Pi, which runs Bullseye 11, Raspberry Pi 4 Model B version 1.4 ARM version. Most important thing from all of this, obviously if you remember your IP address, that's fine. You can take a note of that, but most important thing is the serial number. I'm just going to copy that and just paste it somewhere just to make sure. This is very important because the serial number will be used by Raspberry Pis to detect where to go and what to boot. So this is quite important. Take a note of your serial number of your Raspberry Pi. Press enter. So we're done step 5. We're done step 6. Make image of Raspberry Pi. Before we start this, we need to allow root access to Raspberry Pi. To do that, I'm going to go inside the LXC, inside my SSH, and try to log into this. I think I'm going to be kicked out because I already logged into this before, so my fingerprint might be different. Here we go. So I'm just going to quickly remove that file. So I'm logging into the Raspberry Pi. So this is the same Raspberry Pi that we just created. As you can see, RPi-PXE node YouTube. And I need to change a couple of things here. First thing, I need to sudo nano and change the file, which is located inside /etc/ssh/sshd_config. Scroll down a bit until you see a file called permit root login. Delete hashtag, make sure this is active, and type yes. Control X to close, Y to save, enter to confirm, and then sudo pass wd root, because root password is automatically generated. I don't know what that is, so I need to sudo space pass wd. Pass wd is a command that will change the password and the user root and give it a new password. And once that is done, I suggest to reboot the Raspberry Pi by running sudo reboot. So now Raspberry Pi is basically getting rebooted. So what I'll do while I'm here, I'm going to ping the same IP address, and I'll wait until the Raspberry Pi will come back to life after the reboot. So I'll come back when this is all ticking again. Here we go, Raspberry Pi up and running again. I'm going to Control-C that and go back to a Proxmox. Before I run 0.7, I like to run 0.5 again, just to make sure that this container detects that Raspberry Pi is up and running again. So I can see this one on the list, which is fine. So let's pick the option 7, make an image. 7, enter. And then now I need to give IP address of the Raspberry Pi. In my case, it's 32, enter. And what name I want this file to be named? I'm going to name it Pi for Bullseye. One word. It tells you to use dashes and stuff. I'm just going to use Pi for Bullseye. Actually, just going to use Pi 4 because that's all I have is only Pi 4s. So Pi 4 is going to be the image name. Enter. And this gives you instructions how to allow root access, exactly what we just did. So I'm just going to enter that. Otherwise, if you see these instructions, you go back to do the things to root password, then you come back here and need to restart the script. I just done that before initiating option 7. And give it a password for the root and press enter. And right now, this script connects to the Raspberry Pi via SSH, is installing required packages. It will create a temp folder, which I can show it to you. So as you can see, it's copying the stuff right now into here. So while this is copying, I can go here, log into the same Raspberry Pi, but using the username instead of a root. And if I navigate into a root folder, ls that, there is a folder created right now. It's called PXE. This is the temp folder that the script created and is dumping the stuff in here. If I do, for example, ls, as you can see, there's quite a couple of things started to show up. They were not here at all. So boot files, images, and images. So right now, this script automatically logged in as a root, created a temp folder, and moving all the stuff into this folder to make exact copy, one-to-one copy of the Raspberry and OS. And this image that we're creating now will be used, or can be used, as a master copy for all the Raspberry Pi OS, Raspberry Pi 4, sorry. So this might take up to 5 minutes or so, depending on the network speed and etc. A lot of factors involved, but just leave this running. It's like I said, this maximum should take up to about 5 minutes. So I'll be back when this is done. And about 5.5 minutes, everything's copied. So I'm just gonna press enter on that, and that's it. So the temporary file was created. The script copied all the files for the Raspberry Pi OS into this temporary folder, which basically was linked to this LXC container. So before running option 8 to provision your Raspberry Pi, what I like to do, I'm just going to press Q and just double check if it definitely all works fine, or all the files copied. Well, actually, there is the files copied. So I'm navigating to a CD and just slash to go into root folder. And if I'll ls this list content, there's a folder created, PXE. Navigate into this. And this is contain 2 folders. Boot folder will contain the necessary files for Raspberry Pis to boot. File system will contain the files for Raspberry Pis to function, and images, this is where we store the images that we're going to use to provision of the Raspberry Pis. So if I navigate inside the images and the list of content, inside here there is again 2 folders, boot and file systems. Boot stores the boot files for each Raspberry Pi, and file system stores, for each image, and the file system stores files for each image. So if we will say list boots, boot folder, this is my image that I asked to create, which is Pi 4. And if I'm going to say file systems, so I do see this. Okay, so it means the image is created. Let's navigate back to my script where it is hiding and run the script again. So we're done all the way to a 0.7. So next one is 0.8, provision new Raspberry Pi. So my Raspberry Pi IP address is ending 32, and I know the serial number. If you forgot to read the serial number already, or you don't saved it, you can run right now again the details about Raspberry Pi. So option 6, give it the IP address of the Raspberry Pi you want to provision, the username, password, and this is the ID number or serial number you need to make sure you copy somewhere. So just move the mouse. So 0.8, enter. So provision, what image you want to use to provision this? I want to use Pi 4, enter. Which serial number? So this is the one I'm going to copy from my notes. And I'm going to say this is the serial number of the Raspberry Pi that I want to PXE boot from the server. And the Raspberry Pis will search for PXE server inside the network and look for this particular folder, which is exactly the same as the serial number to boot. I'm going to say this is the one I want. Press enter. And right now what the script was doing, copying the files into this temporary folder, this is exactly the same thing, but because it's doing within the same file system, within the same LXC container, as you can see, it's happened way faster. And now, do you want to restrict access to this file system? I'm going to say no, I don't want. Everything is fine. And that's it. Raspberry Pi has been provisioned. Smiley face. Enter. That's it. And then point 9 is delete the image, and point 10 is delete the provision. So I'm going to queue this. And now I'll navigate into the same folder, which is inside the root directory, and it's PXE. That's where these two folders located. If I'm navigating to a boot, now there is a folder with exactly the same serial number. You know, if I list the content, it contains all the files that it needs to start the Raspberry Pi. And if I go in a file system and this is, as you can see, is quite familiar. This is where your mount is, your home, lost and found, media, etc., user files, temporary, etc. So right now I can go into the terminal while I'm still logged into this Raspberry Pi, and I'm going to say sudo shutdown and press enter. And I'm, oh yeah, okay, sudo shutdown now. And the Raspberry Pi is getting shut down. So what I'm going to do, I'm going to disconnect the Raspberry Pi from the power, take the micro SD card out, and I'm just going to supply the power by a PoE hat without any micro SD card. So let me do that now. So this is micro SD card was used for Raspberry Pi, and right now Raspberry Pi is starting up using a PXE-Boot. So let's ping this Raspberry Pi, the same IP number, IP address, and see once it's going to go up and running. This might take a bit of longer than doing from a SD card, because it's right now going and searching for my home network for a PXE server, a PXE server. So let's wait for a second to start. Okay, it's up and running. So right now Raspberry Pi is up and running using the PXE-Boot. So we can log in back into SSH. Here we go. So if I navigate to this directory where all the files is, this is all the files that you normally would find when you're booting the Raspberry Pi using micro SD card. And if I'll navigate into my LXC container, I am inside the PXE folder, then go in file systems. I'll navigate into a directory which matches my Raspberry Pi serial number. And I can see the same folder. Just to make sure that it's exactly the same, just to show it to you that it's exactly the same, I will go, for example, inside a home. Inside here is Mr. P user, and right now Mr. P user has nothing. So I'm going to say touch test 1, 2, 3. I'll go back inside SSH where I logged into this Raspberry Pi. I'll go inside the home, and here we go. Test 1, 2, 3. I'm going to say touch subscribe, and I'll go back into LXC container. I'll say ls test, and I can see subscribe and test 1, 2, 3. And right now this Raspberry Pi is PXE-Boot, network booting or PXE booting using my PXE server, which is located inside the Proxmox. Let's remove all these folders on all these files. So files gone. Go back in here, and you see files gone. So I was using 32 gigabytes micro SD card to basically use a Rasbian OS and a Raspberry Pi. But right now, because I set my LXC container to have only, only 8 gigabytes, I can go back inside this terminal. I'm going to say df-h. As you can see, the root folder is automatically mounted using NFS server into this location, this serial number, and it only has almost 8 gigabytes of RAM. So right now, Proxmox will do auto backups of this LXC container, and all the Raspberry Pis that I will set up to run a PXE or PXE-Boot from this LXC container will be automatically booted up. If, let's say, this Raspberry Pi needs more storage, I can go back inside my Proxmox. I'll go inside the resources. Let's say, where's my 8 gigs is not enough. You know what? I'm going to resize this, give it another 60 gigabytes. Resize done. So right now this container using 68 gigabytes. I'll go back into Raspberry Pi. As you can see, it's right now jumped to 67 gigabytes. It was 7.8, was almost 8 gigabytes. Right now it's just almost 68 gigabytes. And if I'm doing all the source to this Raspberry Pi and need more storage, it's just going to increase LXC container storage, and I'm going to use it. And this storage will be shared through all the Raspberry Pi. So if I will connect 2, 3, 4, 12 Raspberry Pis to this PXE-Boot or to this PXE server LXC container, they all will share the 68 gigabytes. And now pretty much this is as a normal Rasbian OS. I can update this. Now I need a sudo. I can update this Rasbian OS. Updating. Come on. Update it. Here we go. Sudo apt upgrade -y, and it's running this off this LXC container. So see how it's going. So it's using 163 megabytes and barely doing anything on a CPU. Here we go. It's updating. I can install Docker. I can install stuff. You can't connect USB device to Raspberry Pi. I expect that to work. Well, it doesn't work for me. I tried to connect a USB webcam just to see if I can set up something like a network booting, sort of like a webcam kind of setup using Motion Eye and this stuff. It doesn't work, but here we go. I can use this, and if I messed it up or I done something wrong, I can go back. If I have a backup, I can roll back, and the Raspberry Pi, I just unplug the power, plug it back in, and it will boot to whatever restore point I brought this Raspberry Pi back. So this is how you do a network boot of Raspberry Pi. Me spending 2-3 days trying to figure out. Turns out somebody already did that and made an actual script about it. I highly suggest, I highly encourage you, if you're going to use this and you're enjoying this to this network boot thing, please donate to the creator. I already did that. Off the camera, but basically I suggest to help this guy because he's done this script. It's helped me so much instead of me spending 2-3 days trying to figure out. And I was so close to getting work. It's just Raspberry Pi wasn't detecting the PXE or PXE server for some reason. I know I've done something stupid, but it works fine, and I've been using this quite a lot lately just to mess around with Rasbian OS, just to see what kind of things I can do with Raspberry Pis and etc. Anyway, thank you much for watching. I hope you enjoyed this video. All the links that you need to know, all the information I'll leave in the description below, and I'll see you in the next one. Goodbye.